Rishabh, and I'm currently working as an SDE2 at Amazon. And I graduated from NIT Allahabad in 2016 from Computer Science and Engineering. I've also had experience of working in companies like Visa and Traveloka. So Visa, as you guys know, it's a payment company, and Traveloka is a startup company whose market base is in Indonesia. So without further ado, let's get on to the topic. Yeah. So what we'll be talking about? We'll be talking about the introduction to application development. We'll know how, a basic application used to be developed and how it is, used now. We'll talk a few nuances about monolithic architecture. We'll see what were the problems with it, how people, evolved that architecture, to suit our current needs. We'll see how microservices came into picture as an alternative, and it solved many issues that monolithic gave us. Also, we'll be talking about pros and cons of microservice architecture. Also, we'll slightly touch base on scaling your application and how will you handle large user base when your application starts to grow. Also, we'll touch base a little bit on serverless and cloud computing, which is quite the topic that has been discussed over the recent news as well. Also, I want to touch base on infrastructure as a code, which is also an emerging trend which has been recently started, and I hope not many of you might have heard of it. So yeah, this is all we'll be covering about in next 40 to 45 minutes, and we can take questions after that. Yeah. So let me go by the definition of what is application development. So application development is, that process of creating an application. Application is something, it's any computer program that gets your task done. So if I go by the definition, it says that it's a process of creating a computer program or a set of programs to perform different tasks that a business requires. So if I were to, list down some of examples of what is an application, it could go from as simple as a notepad, or as complex as viewing videos on YouTube. So it can go up to that range. So if you carefully observe the examples I've given, so there are fundamental difference between the two applications. So which is the first one, you are not hosting the application anywhere. You download the build file, you install it on your machine, and you start using it. So essentially, the application lies in your machine and not other server's machine. Whereas what happens in YouTube is you create the application, you ship your code in n number of different servers, and it's the client who will call that server and access the application. So let's say if you were to update your notepad or your Word document, there are versions attached to it, right? So let's say a 2010 version has come in. Next year, 2011 version can come. So you need to update that application. Whereas what happens in YouTube-like system is things get updated every now and then, and you just don't realize it. You just reload the page again, and that's there. It's new update for you. Okay, let's go back in time on how application used to be developed, and that way you'll relate what are the different advantages that we get in microservice architecture. So let's go back in the time when internet was even not there. So what a typical developer would have done, he would have added code to his application. So these blocks I'm representing some code snippets, or let's say some class files, Java files, any code snippet. And you would package your entire application into one build, and you'll ship that product into clients' machines as installable. In Windows, it's something like exe. In Mac, it's something like DMG. So those kind of files, the user would install that executable on his machine and start using the application, right? So let's say you want to add new feature to this application, or let's say after a certain period, internet has come in and you want your users to access this application via a website, something like JSON lint. If you guys are familiar, it is a website in which you put your JSON and it just formats for you. So in that case, what would you change in this architecture? So instead of, so you'll add some more code maybe to make it application specific, you'll package it. And then instead of, giving that binary to end client as an executable, you will deploy it to your server. Now your application, your user base would, have some DNS or, some way of figuring out, hey, this application is at this server, I need to access it. So that's how the user will access that application. So, there is a fundamental, drawback in this architecture as such. So you keep on adding your code pieces like that. So let's say you want to reuse one module with another. What do you do in that case? So, people came with different programming methodologies in which they kind of modularize this application into a multiple subcomponent, which is something like this. You add more code and you create modular. So in this, what happens is, let's say a few of the developers are working in module 3, they'll be able to, communicate or, focus the deliverable on module 3. And if module 3 wants to be used by 1 and 4, it can be reused. So that's how, people thought of modularizing it and creating a better structure so that programmers can benefit from it. But what happened in the right-hand side, it remained same. You still needed to package your application in a single application build file, and then you needed to ship it in your servers. So nothing changed there. So this is a typical monolithic architecture that we call. So mono is something like a single, and lithing is a stone. So this application essentially represents your single stone. So if we were to, represent the entire things that we just saw earlier, we would say that your monolithic architecture has a UI component. It has some business logic that communicates your UI with the database. And you'll have that data access layer, which communicates with your database. And all this is packaged in a single application. And it is deployed to your servers. So let's see what are the disadvantages that this particular, implementation gave the developers. So let's talk about some. So let's say you are a new developer who wants to add new feature to this existing application. So what would you do? Let's say a brand new developer that came into the picture, he understood everything code base, and he wants to add this blue colored box into module 4, which is essentially his new code. So what would essentially happen? He would have to understand the entire code base. He would have to make sure he's able to test that entire application, which means that he has, some fair bit of knowledge of module 1, 2, and 3 as well. And he needs to build everything and make sure it doesn't break anywhere. So this is essentially the expense of, a new person contributing to this particular architecture. The entire application need to be tested again, because his particular code in module 4 can potentially bring down the entire system. So this is what, the problem that has been created from monolithic architecture. So let's move ahead with other disadvantages. So when your user base grows, right? So what do you do in that case, in considering this is your current architecture? You take your entire application, you spin up multiple instances of servers, you take that entire application of all the modules and you host in different servers. And you have something like an interface, which we usually call as load balancer, and we give access that to users. So what is the flaw in this architecture? So if we were to list out some of them, so let's say there has been these 4 modules represents a e-commerce website, and module 1 is essentially your order history thing, and module 4 is an interface which gives out that shopping experience to the user. So in that case, let's say Amazon or someone has announced a Prime Day, which is going to come soon, right? So in that case, only traffic to module 4 is expected to increase and not to module 1. What happens in this case is all your resources, get filled with this application, including module 1 part. So your scaling works on entire application and not at module level. So this is another issue that has been created, and we call it scaling. So if I were to summarize what we talked about so far, so we talked about that it has a single code base. You keep on adding to it, and perhaps you can modularize it, but essentially it's a single code base. Other than that, it has a single build system, right? This is quite important when we talk about monolithic. So by build system, there can be multiple build system. Like in Android, you have Gradle. In Spring, you have Maven, something like Ant. In this monolithic architecture, you should have a single build system which should be able to, compile and build your entire modules together. And that has to be uniform. So even if you were to code in different languages for each of the module, you'll have to have some wrapper around it so that it can be compiled as a single output build file. So that's the essence of that having single build system. Next thing that we come to know is that it has a single executable or a deployable binary. So a point to note here is this is also sometimes called as multi-tier architecture, because it's divided into like 3 tiers, like presentation layer, which we talked about, UI part, the business part of it, and the application part of it. Coming to limitations of it, we talked about some in detail, like it is quite complicated to understand a new developer. The bootstrap time for a new developer is quite huge. Scaling, we saw how, if you're, some modules needed to be scaled, you had to scale the entire system. So this is another. There are few more that have listed down, something like CICD, in which I think you had a session about CICD. So that becomes more complex in this application, which contains entire module, and your, CICD needs to take care of building each of the components together and then packaging it together. So there are more chances of failure there. So in a typical enterprise world, since the application is not that simple, you might have to require a dedicated team for this. When your code base increase, your IDE, your whatever IDE you are using, IntelliJ or Visual Studio, for large code bases, it is directly proportional to your build time. So your build time will increase, your developer efficiency will decrease essentially, right? So if you, some of you have explored Android development, you might have observed that your building Gradle takes like enormous amount of time, and your efficiency is essentially decreased, right? So that's what I mean by overloaded IDE. Next point is it's extremely difficult to change the technology behind it, because you have a single, a build system. That's how, so this is the essence of that, how complex it can become to change if you were to change a single piece of technology in your application. Also, since it's packaged together, it's tightly coupled. So if I were to define tightly coupled, it's something like when one of your change, it requires, changes in multiple things, or to put it this way, if you make one change, you have to, take care of all the references in multiple places. So that's how, typically we define like tightly coupled and loosely coupled. Yeah. So moving on, what brought about the shift? So earlier we didn't have smartphones. Smartphones were of limited capability, and the single point of accessing this web applications or any applications per se that was hosted on servers was website. So with the advent of technology, the endpoint or the end user started accessing this data or application from different sources like mobile, smart devices, n number of devices. We have IoT that is bringing on whole new revolution. Also internally within the organization, there may be some analytics team which may require access to some of the modules. So this is what, the general problem that brought about a shift in this programming architecture. So we'll move on to the next section. But before that, if anyone has any questions around this.
Not yet, Rishabh, we can go ahead.
Sure. Great. Okay. So, how would you change your existing application, which looked something like this, to more flexible to solve some of these issues? So, what would you do is you would decouple your application into multiple services, and after you decouple, you need an interface to for your communication with multiple modules, right? So that interface is essentially called API, which is extracted into long form as application programming interface, and the communication between them is done by a protocol, that is REST protocol. REST is a widely used protocol for these sort of communications. There are more like SOAP as well. Yeah, this is a typical representation of how your multiple services would interact using APIs and REST, and these individual components are your microservices. Yeah, that's essentially the gist of it. So yeah, if we talk about large enterprise application, right, like Amazon itself, so it cannot keep on building that monolithic way and segregate their task of able to deploy test individually. So that's the essence of this architecture, in which each of the module can be owned by maybe separate teams, and they can they can develop on it, they can deploy and test individually. Whereas earlier we saw that deploying anything into that monolithic architecture requires an extensive testing of the entire application. So that issue is resolved here. Also, we saw that communication between them is done by a popular protocol called REST. And the format that is generally used is JSON. There are other formats like XML as well, but the most widely used one is JSON. Yeah. Also, here each service may have its own database, whereas earlier we saw that each there was a single database layer that had the entire logic of keeping the data stored for any system. So here each services can have their own database, and that can be shared across common usage as well. Yeah. So this is a typical representation of your microservice architecture, and it essentially looks like this, where you have your UI component, you have each of your microservices. These microservices communicate with each other, and they get deployed to servers individually. So how does this thing solves our initial case of scaling that we have? So let's say one of your microservice, let's say second one, represents your shopping module, and you have some other module which represents your order history, which doesn't require a scaling. In that case, you'll just take this second microservices, you'll add the required number of hosts to it, and you are good to go. You save on your cost, you save on your infrastructure setup time, and that's the essence of how the scaling issue is resolved here. Moving ahead, we talked about some of the benefits. Just to reiterate them, so each of the microservices is small and focused, so you can have better developer agility on it. It can be developed independently, which means if you were to scale your organization into multiple teams, and multiple teams taking care of each of the microservices, this architecture would better suit you in terms of you can focus on what really need to get into production, rather than maintaining all the infrastructure DevOps thing. So this is the second advantage that you get from this architecture. So we talked about tightly coupled earlier. So microservices is said to be loosely coupled. If you design it in a correct way, it means that a change in one service need not trigger any change in other service for one particular feature or development. So this is what we mean by loosely coupled system. Moving ahead. Yeah. So again, talking about CI/CD part, we have a bunch of tools, like Jenkins, Hudson, Bamboo, in which the continuous integration of this individual microservices can be, it can be easily maintainable and deployable. So the productivity of a new developer, it will be quick because he need not understand the entire modules that we have, and he can focus on his task of delivering his thing on single module, and he wouldn't have to care of testing the entire application before shipping his code to production. We talked about scaling earlier on how, based on demand, one of the microservices can be scaled, and based on demand, you can actually take one service and choose not to add servers to other machine. So it's like an elephant versus ant approach. So what you want to build a giant system like elephant, you take army of ants, which is small, fast, and effective. So this is the analogy that we use to compare monolithic and microservice architecture. Moving ahead, there are certainly cons to it. So this is just a programming methodology, right? It need not solve all the use case, and let's say your use case is more suitable. There can be use cases which are more suitable to monolithic architecture than microservice. So it's not the say of the written in stones that you need to use microservice architecture. But if we consider large scale distributed application, microservices is generally the way to go. So if we talk about some of the complexity here, let's say I talked about over complexity. If one feature, it triggers change in tens of different microservices, then perhaps your microservice is not correctly designed, or microservice architecture is not the way to go then. Other con is like discoverability of microservices. So you'll be surprised to know that if you see the graph of Amazon, the number of microservices and how they interact with each other, it will look something like a very closely knitted, globe where you have connections from each and every thread, and it's very, very, cumbersome and complex. So in that sense, if you were to discover a new feature, let's say I want to use something that is already there in the microservice and that is already been developed. So, documentation of those and making them discoverable using proper API request and response can be a challenging task. So this is one other con to microservice architecture. Moving ahead. So we'll talk about how you typically deploy your microservice into, the actual production code and what are various end types of systems that you can use to, deploy your microservice. So let's say the top half of the section, these are your clients. So I talked about load balancer earlier. So load balancer is nothing but a single endpoint or single point which is referred by all your application clients. And behind that, you have n number of different servers. So the typical load balancer algorithm can be like round robin, where user 1 request goes to server 1, user 2 request go to server 2, and so on. So there can be multiple algorithms that you can attach to your load balancer so that you can, you don't have to, you can, manage your underlying hardware better. So that's the essence of using load balancer here. You can scale in and scale out as much, as per your need and your traffic. So talking about the bottom half of this diagram, we are talking about what are the choices that you have, when you deploy your code into actual machine. So you can either take, bare metal or bare machine. You can install your server code there. Let's say you are using Apache, then you have to install that Apache server there. You'll have to host your application there. Other option is virtualized, in which you have virtual machines already installed, and you can use these virtual machines to, use one of the server to, deploy multiple small number of applications. So that's the use of hypervisor and virtual machines here. If I go on to the third option, we have containers. So containers are, gaining much popularity recently with, you might have heard about something like Docker, which provides, a container solution to your application. So what it essentially does is it packages your application into containers such that these containers are, fully fledged and managed, and it can be deployed individually into your servers so that you can better scale your application. And these containers are essentially one part of your one microservice, I can say. Yeah. Also, moving on to the fourth option, we have public cloud, in which you might have heard about AWS, Google Cloud, Firebase. So all these are public cloud in which all the management part of it, let's say you need to scale in, you need to scale out, and you need some dedicated managed servers. You need to take care of security, you need to take care of authorization and authentication. So all these things comes, managed in this public cloud. So that's the essence of this deployment of your microservice. Moving ahead, as I talked in the previous slide, it can be deployed in a variety of ways in serverless architecture. Moving ahead, this is more or less what I covered in the previous section. So talking about auto scaling, how does it really work? This is a very fancy term and widely used to manage cost when there is a traffic increase to your website or application. So in this, what happens is you define a minimum size of number of machines you want to use. Also, you define a maximum size you want to use. So suppose you have a hardware which is of 1 gigabytes of RAM, and it has some specified network bandwidth, and it has some cores, like let's say we have some CPUs like 4 CPUs or so on. So let's say we have this kind of machine, and you are aware that your traffic can range from 10 requests per second to almost 40 requests per second, and you want to keep some buffer as well. So in that case, you may want to use auto scaling groups in which you are specifying a minimum size, you specify a desired capacity size, you reserve some of the boxes so that you may or may not scale as per your traffic. So this is essentially how auto scaling works. This concept will quite be useful when we talk about serverless computing in the upcoming sections. Moving ahead. So cloud computing and how does it help us? So in cloud computing, your cloud provider like Amazon or Google, it runs the server. It dynamically manages your allocation of machine resources, and your pricing, it is based on the amount of resources that you consume by an application rather than pre-purchased units of capacity. So I've given examples of two types of traffic pattern. The first one, it represents a fairly constant traffic pattern. Let's say you have a YouTube kind of website in which the streaming goes on quite regularly, and it doesn't have any spikes as such. On the other hand, let's come to the second one, second traffic pattern, in which your traffic is stable and it takes a sudden spike and then again it goes stable. So let's talk about websites like Book My Show. So if I were to relate it, maybe they would have traffic on majority on weekends because these tickets of movies gets booked on weekends more. So they'll start increasing their traffic on Friday. They'll peak at maybe Saturday or Sunday and then drop down again on Monday. So these are two different types of traffic pattern. And if we were to use serverless in this, so let's talk about how choosing of one type of build system in the backend can impact your pricing. So in the first example, if you had some dedicated host like 2 machines or 3 machines, which generally keeps your CPU utilization to about 70%, and it is able to be available for this kind of traffic pattern, then I think you'll just give price, you'll be billed for those 3 machines the entire unit of time, right? So, and talk about the second pattern. If we were to apply the same 3 machine in this second type of traffic pattern, it will mean that your CPU utilization goes to about 10% on weekdays and about 90% on weekends. So that's not essentially a good utilization of your resources, right? So in that case, auto scaling can come into handy, where you can specify your min and max capacity. What is also popularly used these days is serverless computing, in which you are only built on the type of amount of resources that you consume at a particular moment. So let's say at Monday you consume only n units of those resources, so you will be built accordingly. And when your traffic spikes, that underlying machines will scale up accordingly, and it will you don't need to take care of availability as such. It will just scale your machines for you, and then you are good to go. You are good with scaling, you are good with availability, and that's how you take care of the scenarios. So some of the popular serverless options that we have in market is AWS's Lambda. If we were to only talk about compute part of it, there are some serverless options for database as well, like DynamoDB for AWS and other managed services. But only for the execution of your code piece, these are some of the popular options. That's Lambda, and other is Google Cloud Function. There are other providers as well, but these are the most commonly used ones. So if you want to really explore some of these technologies, you can actually go ahead and create AWS student account. I guess with your college email IDs, you'll be able to access these resources in a free tier environment, and you can try it out as well. If you are not able to do that, it generally requires a credit card. But from Google provider, there's something called Firebase, and Firebase is essentially, it works in a free manner with just a Gmail account. So if you want, you might want to explore that as well. It has some very good number of hosted services that you can explore. Right, moving ahead. So yeah, this is the final topic that I wanted to touch base on. It's called infrastructure as a code. In this, essentially, previously what used to happen is we created our infrastructure manually. What we used to do was we created, if you might have used something like LAMP in college, it used to install an Apache, it used to install a XAMPP server in which your PHP code used to run. It also gives some of your database options to you. And you essentially had to deploy it in your machine. So imagine if you were to scale this in thousands of machines. So you'll have to make some sort of, automated code or something so that it can individually deploy to individual machines, right? So what recently these companies, Terraform is a company in itself, and CloudFormation is a service of AWS. What these providers have done is they have created or simplified the way we imagine infrastructure. So infrastructure, typically, if we spin up the instances, we put some attributes or environment variables there, and we deploy it in one region or somewhere. So if we were to convert the entire process into code, what will eventually happen is there are less chance of making a mistake, first of all, because a code can be reviewed by a third person, and he can point out that you have so and so errors in your configuration, you should correct it. Other important advantage of this is if you are providing some of your application in India region, you want to you saw that there's an opportunity to get some market in US, Brazil, and so on, other places. So you want to deploy the same application in servers which are present at that location, because if you are to access something from India to India server, that will be relatively less latent. The time consumed to get the request and response back and forth. So you may want to deploy that in the same region as your marketplace. In that case, you take the same code and you can just tweak in some of the parameters and you can deploy anywhere. So the expansion becomes very, very easy by using of these technologies. this is quite widely used recently, and wanted to touch base so that you guys have some fair idea about what is going on recently. That's pretty much it from my side. We can take some questions now, and you can definitely connect with me on LinkedIn or email for any other questions or help. Yeah.
Hey, yeah. Thanks, Rishabh, for the session. And yep, we have couple of questions as well. So let me narrate them. You can answer one by one.
Sure.
Yeah. So we have one question from 𝙍𝙤𝙨𝙗𝙗𝗔𝙬𝙗𝗍𝙠. So she's asking about some general characteristics of microservices. I mean.
Okay. So if we are going to talk about general characteristics, you may want to think in a way that is your application scalable independently? If the answer to that is yes, then certainly it categorizes that your application you are building is a microservice. Also, some of the other aspects that we talked about, that whether it can be tested independently, whether you can expose an API on top of that so that it is reusable. So these are some of the key components that you take into account when designing any system and keeping it the way the architecture lays out, essentially. Yeah.
Okay. All right. So yeah, next question again from her. What are the authorization protocols we use in microservices?
Yeah, Shashank, is there any other question?
Oh, I'm really sorry, I was on mute.
Sure.
So yeah, again, the same question is from Saroj Kumari. She wants to know what are the authorization protocols we use in microservices.
So talking about authorization protocols, so if we are going to talk about managed services, some of the services like API gateways, they intrinsically take care of all these authorizations that we have in place. But if I were to list some of them down, I'm not sure exactly about what protocol it uses, but it takes care of all the DDoS firewalls for you. It also takes care of rate limiting for you, meaning by, let's say, if you have happened to use any of the developer APIs in your application, let's say you are using Facebook for login or Gmail for login, all these companies have exposed their authentication and basically authentication mechanism to its users, right? So in that case, all these companies, it's very important for them to rate limit their users of these APIs. So let's say if something is provided on pricing, then on a free tier you can provide some 50 requests per second, and on a paid version you can bill them on number of requests that they hit correspondingly. So all these things are taken care by these API gateway sort of service that we have. But to be specific about protocols, I'm not really sure of that.
All right, Rishabh. Yeah. So we have next question from Megha Saxena. So what are the challenges you face while working on microservice architectures?
Good question, Megha. So the challenges, so the concepts that I listed, and explained before, it's very important, to know your traffic well, know your the purpose of your application well, and distribute your service in a way that it is truly microservice. So microservices is nothing, it's essentially a group of services, right? But microservice architecture is essentially that gives you that best practices and nuances of to how you can really benefit from it. So the major challenges, I would say, is around scaling part. If you don't scale your application well, you don't make the right choices. Let's say I talked about this traffic pattern, right? It's quite an you may say this is just a definitive term, but people have actually faced issues in this sort of traffic patterns They have went back and saw what kind of, backend service suits for their traffic pattern, and they've saved, millions of dollars. And this millions of dollars are, essentially reflected in your portfolio or data that we call it in your, good work as such. So these traffic patterns and how effectively your service is loosely or tightly coupled, all these things, are taken into picture when we design any of the service using whatever the backend service may be. So recently, what we have seen is these cloud providers have done tremendous job in providing that managed services for all of us. Like Elasticsearch is managed. DynamoDB is a very popular database that provides a single-digit millisecond latency. So what I mean by that is 90% or 99% of the time you are expected to get response in single-digit milliseconds. So that's under 10 ms. So that's how fast these backend managed services have created for us. So all we need to do in design choices is choose this backend service carefully, such that we optimize on cost and we are able to keep up that availability part. So for freshers, it may not be as critical topics because it won't really be asked in your interviews. But as you go up the ladder, you go to senior developer, you go appear for SD2 role, then these sort of nuances come into picture in your interview design round and also in your day-to-day life as such, because you start with any project by creating that design choices, backend choices. So yeah, that's pretty much it. If that answers your question.
Yeah, all right, Rishabh. I think that answers her question as well. So next question is from Salab Saxena. So he's asking, what is the use of packed in microservice architecture?
I didn't hear that part. What is the use of packed?
Packed. I also don't know this term. PACT.
Okay.
Packed.
Packed. Salab, I'm not sure if you can, expand that terminology. Maybe I can give more insights to it. But as of now,
yes,
not really sure of.
Salab, I would request you to explain your question more. Meanwhile, we can move to other question. So next question is, we know both architectures, monolithic and microservice architectures, right? So how can we decide when to go for monolithic architecture and when to go for microservice architecture?
Yeah, that's a good question and fair question, to be fair, because both the architectures have their own pros and cons. But I would say maybe a thumb of a rule for deciding on the major thing is whether your application has a lot of distributed endpoints into picture, whether your code base is really large enough. So anyways, people start with monolithic architecture most of the time. I mentioned a startup I worked with, so their entire code base was monolithic when they started. But with multiple rounds of funding, they had become so huge that they initiated a project of converting their monolithic architecture into microservice, because the complexity that was involved in the DevOps part of this monolithic architecture was not justifying the developer cost that worked on it. So to be more precise on the design choice, I would say some of these aspects that I covered, like size of your code base, the testability of each of your modules. So if these are getting out of your hands in monolithic architecture, then you might want to consider microservice architecture. And also, let's say you have a web service which is only used by your application, but in the future you envision that this API is really cool, I can expose it to other open forum as well. So that's how these big giants, every big company that you say, they will have developer APIs in them, in which developers can come in and build their own applications. So almost all of them have at least a login page, login APIs exporters, right? You can log in with Facebook, Gmail, and n number of different social websites in any of this website that you come across. So essentially, this entire component of authorization of their, identity, it has been exposed as a microservice so that it can be later, exposed as an API. So these are the sort of things that you need to envision so that you can properly decide on whether you need to choose monolithic or microservice architecture. Also, you need to be careful that I just mentioned the cons of microservice, that you might sound the term very fancy and you might think, hey, there are so many good benefits. But maybe to start with, you have a fairly small code base and things can be, clubbed into single application better, and there are less chances of, making changes in one place, it is more convenient and, less developer time consuming and less build time. Testability is not a problem. So those are some of the attributes that, you can consider while choosing between the two.
Okay, thanks Rishabh for answering this question. So we have one last question from Vidushi Singh. She wants to ask, what is fog computing and how it is different from cloud computing?
What is FORK computing? For computing?
I don't know. Fog. Is it any term related term? FOG, fog computing, or it's a fog?
I'm not sure. Can you repeat the question once?
She is asking what is fog computing and how it is different from cloud computing.
I have not really heard about this term, but I can lay some of the light on cloud computing more. If you know what is fog computing, maybe you'll be able to create the difference between the two. So in cloud computing, what happens is it's a managed service, which means the compute part and the management part of it is taken over the cloud. So let's say the current thing that you are viewing, right? It's something like Google Slides that I'm using. So it's completely cloud computing. The application is completely hosted on Google's website, and I'm using this interface to interact with it. So this is a good example of cloud applications and cloud computing. Other aspect to this is some of the services like Lambda functions and DynamoDB. So what happens in these applications is you don't take care of the underlying servers at all. I mean, you cannot even SSH to the machine that actually serves your request. So that's how managed these services are. So you just need to deploy your code, and the rest of it, it is taken care in the cloud part of it. So yeah, just to throw some light, these were some of the good examples that I can find. So probably if you know fog, then you can create a comparison between the two.